You can see my screen for a start, and everybody can hear me. So thumbs up from a few people there on the picture. So great, thanks for that. Okay, so my name is Cormac Lyons, and I'm Managing Director of a company here in Limerick called Procad, and we're an Autodesk reseller. And today's presentation, I suppose, is just titled The Art of the Possible, because that's what the Autodesk branding has delivered to me in terms of their PowerPoint template. But what I'm going to look at is, I suppose, initially just the trends within the industry, manufacturing trends globally and here in Ireland, and predominantly among our own customer base as well, because what typically are the trends globally are usually the similar trends that our own customers are experiencing. So just a little bit about ourselves, first of all. We're Limerick based, although we operate all over the country. We have an office in Dublin, and we work predominantly in Ireland, but in the UK as well to some extent, and across Europe, and a couple of customers in the US. We're operating for over 20 years. We've 20 employees, and we also have a number of contractors and trainers who are kind of specialised in their own fields of expertise. We're focused predominantly on manufacturing and the construction markets. So in terms of Autodesk branding, that's the MFG market and the AEC. AEC standing for Architecture, Engineering and Construction. We tend to try to remain as customer focused and solution focused as we possibly can. Most of our customers are actually people we are engaged with in terms of either a project or an implementation or a complete training plan. Obviously, we are a reseller and we do sell product to customers who are typically, as a result of our manufacturing customer base, we would have a closer relationship with our customers, understanding their day-to-day workflows and what their typical challenges are. And we've also then migrated to the construction market and have a similar customer type profile in there, where we work closely with our customers and we deliver solutions specific to the projects that they're involved in. As I said, we're an Autodesk value-added reseller, so predominantly our product range is based around what Autodesk offer, but we have other solutions as well that might enhance those offerings from Autodesk, or may add specific functionality that could be required. And one example of that is the product Woodwork for Inventor that I know was covered in one of the previous presentations, but we might have a chance later on just to have a quick overview of it again. Our focus typically is around management of data and the creation of that data and how that data moves throughout the organization. Obviously, we focus on sales as well, typically the products like AutoCAD, Inventor, Revit, 3D Studio Max, Navisworks. So all of the Autodesk products that you might be familiar with already, chances are we probably sell them or have customers who are using them. We provide training, consultancy, and of course support across all those products as well, to try just to enhance the user experience and try to make sure that our customers can adopt the technology in a seamless manner and a more kind of cost-effective manner. So that's a little bit about ourselves. And today's, I suppose, title, I think the paragraph I read regarding this presentation was to do with the manufacturing trends of Indigenous companies here in Ireland, and they're typically who we would work with on a day-to-day basis, and who I have personally worked with for probably, I'm not say 20 years, but it could be 30 years now at this stage. But basically, I decided this morning to have a quick look at Google and, what are the manufacturing trends that are in the global marketplace. And I just took two kind of random lists, and I said I'd run through those and just see how they compare with what we are experiencing ourselves. So the first one came from just a search, and it was kind of based on Gartner research and Polaris and Allied Market Research. So various different research organizations compiled this list. So the first one being mixed model assembly expands with more changeovers than dynamic production. So that's a bit of a mouthful, but at the same time, typically what we're experiencing is that customers are looking for more specifically customized products. So the ability for manufacturing companies to adapt and change and allow those specifically featured products to be manufactured and assembled. So that's a kind of a customization trend within the industry. Also then the connected workforce thrives, and that's to do with just basically how connected all of our employees and workforce are today in terms of tablets, the wearable technology, and then in construction or out on site, things like smart glasses that allow people to have an augmented reality of what the design is going to look like versus what the actual design, what's physically in place. So just connecting workforce and making sure that people have information wherever they are in the various environments. Following on from that, the wearable technology is expanding. I suppose in most cases, we look at wearable technology as in smartwatches and so on, but some of those tools are making their way into the industry where, again, things like wearable glasses and virtual reality goggles allow us to explore different design ideas in a virtual world or in an augmented reality world. Number 4 there is the increase of adoption of 4.0, that's Industry 4.0, and the general technology and data that's extracted from equipment and machines and from throughout the manufacturing processes, and trying to introduce automation and just improve workflows in general. The growth of the educational programs of manufacturing technology, so there's a lot more educational programs available for technology that exists today. The trend is moving away from kind of general assembly and moving into kind of robotics and automation. So obviously the education surrounding that is very pertinent and important. Onshoring, that's a welcome trend, I think, for a lot of us here in Ireland, especially. Where a lot of stuff that previously would have been sourced offshore is now being sourced more locally and being produced locally, which is fantastic for all industries and the economy as a whole. Capital spending for manufacturing technology, definitely another trend. There is an increase in capital expenditure across the board. We see a lot of our customers investing in new machinery and equipment and automation and robotics. So that's significant there for all of our customers. The introduction of robotics, as I said there, is quite significant. We have a lot of customers who are automating some of the workflows and some of the assembly processes and manufacturing processes across all industries, from light manufacturing and the wood design, we'll say, or wood manufacture, right up to medical device polishing and finishing. As a result of the Industry 4.0, I suppose cybersecurity is a significant issue, or potentially could be. So that's always a prominent conversation that we would have as well with our customers. Obviously, big data, following on from that, the information that's collected from all of these equipment and machines, and the data that's created, where has it been stored, how has it been managed, and then obviously 5G as well, the fact that this information is now available wherever we are, wherever we go, we can review and analyze the data and actually add to it and produce more data on the go. Then another trend finally then is the COVID-19, how companies have responded to it, how they plan on recovering from it, and then how they plan on renewing their strategic objectives following on from COVID, when eventually we get back to normal or some level of normality. So that strategic review would be based on the learnings as a result of COVID. So that was just one group. I decided to do another search there on this other site, Hitachi Solutions. The employee safety is a top priority. The Internet of Things, predictive maintenance keeps production on track. So the cost of downtime on machinery just at this point can be significant. So obviously predictive maintenance and trying to anticipate downtime and avoid it ultimately, and avoid these costly downtime periods. Shifting focus from business to business to consumer. So manufacturing companies are planning on trying to penetrate the consumer market directly rather than going through distribution or through suppliers. And so that's obviously a trend, and obviously the customization of products to suit those individual customers is prominent and pertinent too. Manufacturers plan their COVID-19 exit strategy, the same as number 12 above, and that's a significant trend. And then a new approach to ERP, the data flowing through an enterprise, what your stock levels are, what your costs are, part numbers, production schedules, and all that. It's just, collating all that information and keeping it all under one roof. And then manufacturers gain greater visibility into big data, where they're actually capturing the information and seeing where they can look for improvements and look at their metrics and hope to utilize big data to improve the manufacturing process for themselves. The trend there mentioned is VR and AR, as we said already, but this is a trend towards a touchless service model, where maybe equipment out in the field, somebody could utilize augmented reality or virtual reality to review the equipment and identify where the problems exist and instruct maybe somebody more local to on how to repair it or how to modify or resolve the issue. So that's actually something we've been involved in ourselves with one of our own customers. The next one then, 3D printing makes production faster and cheaper. We're all hearing about 3D printing now, and obviously they're very prominent in the market, and the cost of them has come down significantly. So a lot of companies have adopted 3D printing where relevant or where it can help out in their production processes. Manufacturers reevaluation shoring and sourcing, so that's similar to above. And then the job market remains uncertain. Obviously, there's uncertainty in every market, but the job market currently, manufacturing companies are hoping that they'll be able to resume the previous levels, but I suppose at the moment it's a bit uncertain. But the introduction of automation as well is certainly going to change the market. So people, rather than actually involved in assembly, they might be involved in managing equipment that does the assembly for the organization.
Okay, sorry, can I come in there, Cormac, just for a moment? As soon as you're ready, we'd like to get on with the presentation. That's all very useful, but I'm anxious to see Ray's presentation.
Okay, is it the Woodwork for Inventor that you're mostly interested in?
I think so, yes.
Okay. So just to follow there from the sustainability, or what I thought in terms of the trends, sustainability has to be essential. The environmental impact, focus on innovation, on product and the manufacturing, improve quality, and obviously, that has to be ongoing. And then training, upskilling, and pass down of skills, especially in the woodwork industry where it's going to be essential. What we have here is a presentation which is relating to the I suppose the marketing approach with Autodesk and how they interpret the customer data flowing through an organization, and how it tends to be pretty much all over the place, and trying to gather that into a connected workflow. So typically we have a disconnected workflow where, when it goes from design to manufacture to engineering, it's disconnected. So there's a lot of lost data, rework, and delays in that process. So typically those delays can result in as much as 21 hours per person in a week, which is significant. So Autodesk take the traditional approach. Instead of having, sorry, I'm just trying to move that. Instead of having a fixed product value through the process, which typically we would normally have with the traditional product life cycle, they've decided to introduce an increased value approach, an increased lifetime value, whereby there's additional components of the product life cycle that would allow for customization, collaboration with the customer, and also flexible manufacturing to address those mass customizations, and obviously the customer experience, and then trying to add value by adding smart devices. And that's a typical trend in the industry as well, trying to add value to the product so that ultimately we have an increased lifetime value from our customer. So rather than going through all of the improved connected digital workflows that Autodesk have presented and that we have contained within our Fusion lifecycle, I can skip forward and go to the Inventor Woodwork for Inventor presentation, which was supposed to be a smaller element of my presentation, but I can skip to that. So historically, or previously, you have received this. Are you seeing my screen still?
Yes, we can, yeah.
Okay. So previously, you would have had a presentation from Ray and Tobias, and basically they ran through this new product that we have introduced here in Ireland called Woodwork for Inventor. So most of you know already, Inventor is a 3D parametric modeling tool. It's an associated 2D drawing. So as we change the model, the 2D drawings are updated automatically. We've got visual capabilities, bill of materials, sheet metal outputs as well to allow us to unfold components, and then it's rules-based design, so we can enter values and ensure as well that if there's rules to do with our designs, they can map onto our CAD application as well. So, and we also have a tool in there for frame design, which allows us to extract a bill of materials, miter the ends, and identify the locations of holes and so on, so we can produce a detailed bill of materials specifically for the frame. which would include weld details, and obviously if there was sheet metal components as well, that they would be folded up. The layout for factory utilities when the collection based within the collection, so you can do complete layouts of organizations. And then we have a large standard parts library as well of individual components. And very important today is the ability to interoperability with products like Revit for the construction industry. The output of models from the Inventor environment so that they can be used by our construction collaborators and partners in their overall construction models and building information models. So Woodwork for Inventor, so it's just a combination, it's an additional tool that sits on top of the core Inventor product. It's designed specifically for woodworkers, and it's designed to accelerate the manufacturing process and enable users to generate more complex, and by automating the generation of cutting list and interface a variety of CNC machines. So just to combine all of the workflows and the processes involved in the production of wood and wood designs, and allow them to be manufactured effectively and cost effectively and quickly. So there's a typical workflow here that we have for Woodwork for Inventor. And obviously it starts off with the base skeleton model, and then we can kind of box it out and kind of decide where we're going to put our shelves, and then we can apply the materials, and then we look at the hardware, the runners, the hinges and so on, where they're all going to be located and fitted in. And then we have a bill of materials that can be extracted from that model, allowing us to produce drawings that can be used for general arrangement, and also for to specify the exact design of that we've created, and also allow us to export information directly to our CNC machines, so that those materials and components can be cut out. And then we also have a feature in there for nesting that allows us to take those components and nest them into boards. So we're optimizing the use of our raw materials, so we're getting the max out of our cutting sheet every time. So rather than me running through all of the features, I think I can do a general overview, Bill, if you like, or we can kind of look at some of the functionality in the video. And if Ray wanted to join there, Ray, you could actually describe in more detail maybe some of the functions.
Yeah, I think if Ray came in there, it would be very helpful. Cormac, okay?
Thank you, Bill. Thank you, Cormac. Yeah, so just to kind of give an overview, we covered this in the last presentation, but just to kind of give you a simplified overview. So basically here what we're doing is we're just creating up the features that we require and just kind of giving you the overall shape and size that's needed. And the reason why we're doing that is we're making the part intelligent for reuse downstream in both nesting, both fabrication, and so forth like that. So here what we're doing is we're building in all the parameters and the spacings that we need. And this allows us to change the model as we need. So many times what we see with customers is they would develop up something, they would generate something, but they need to change that on the fly. And that's what we're trying to do here, is to change things effectively, easily, and then to be updated downstream, as I said. Here what we're doing is just building up the panels, building up the carcass or the units that we're looking at here, and we're reusing that parameter detail. We can put in information such as the copy of components. We can actually size those, referencing off a top panel or a bottom panel here, as you can see. So again, we're using all the information that we need, and we can control those, and we keep adding those as we go along. Once we have the kind of overall shape and skeleton kind of defined in this case, what we can then do is we can start adding some in treatments, trimming the uprights, for example, trimming the back face, and then what we can do is we can add in joints such as miters, etc., etc. And these are automatically put in. We don't have to individually draw these in. This is automatically taken. So it's very much like drag, drop, click, and we put those in place. So we're kind of really kind of speeding up the process. You can see here we can make modifications on the fly. We can control, again, we're using all our parameters and finishing it out really from there. So again, it's very straightforward and simple to use. It's very intuitive. So anyone that's got experience with AutoCAD, for example, or even SolidWorks, and it's very, very straightforward and easy to use. So you will understand the user interface very quickly and easy. So we're just adding up a few bits, just defining the front cover panels there, for example, and we're going to move on pretty quick. So there's quite a lot of information shown in the video. But we're happy to share these videos after if anyone would like to quick review those again, just to kind of get a better feel for it, okay? So once we have the kind of the overall item defined, you know, I think Cormac, you need to move on to the next slide if that's okay. What we then do is we kind of make it smart. So you can see we've just drawn it in kind of one piece. So you imagine that if we just got one lump of everything just drawn in one confined folder, now what we're really doing is we're making components. We're making this into assembly. So the reason why we do this is we talk about bill of materials. We talk about BOMs. We talk about building up and making our BOMs intelligent to include further information. I.e., for example, the screws are used, the connections are used, the guide rails are used. All that information is reflected in the BOM and updated. So you can see here what we're doing is we're adding in some material types, and again, pulling from a library, I might add. So what we would tend to do is we'd use libraries quite a lot. So we have a library of content that's parametric. So this door could be in the library, but it's got flexibility to size and shape as we require per our design. So again, you can see using built-in iLogic formers, what we can do is we can change the functionality is opening left, it's opening right, handle type, that type of stuff. And again, in this case, what we're doing is just finishing off with a number of patterns there as well. So once we have that defined, you can see we can mirror, we can bring across the other component to close out. And again, when we mirror something, this is not just mirroring the part for the sake of it, it's mirroring all that intelligence as well at the same point. I think, Cormac, at this point we could move on, if that's okay.
Yeah.
So again, one of the big things we find, and one of the things that we do need to note with a parametric design tool like Inventor or Woodworking for Inventor, we can get very easy caught in the trap of it's one single component. Obviously, in the industry that you're involved in today, it's layers, it's made up of multiple composites or multiple layering of parts. So we need to be able to see that in the bill of material, and that needs to be reflected in the information here. So again, Cormac, if you don't mind. So you can see we can control what is shown on the part. How is that seen in the BOM, especially for manufacture, especially for nesting. And we also can group those as well, which is key to a lot of this. So again, Cormac, please. So this is kind of a video where it goes through that, where we can look at the part composition and the bill of material level of control within this particular design. So you can see here, I think, yeah. I'm blaming Cormac for this.
I'm going to go on there. It's not,
okay.
It's not working there.
Okay. So again, going back to the workflow with Inventor for woodworking, we need to define that we've built up our skeleton model, we've defined the structure within that, we've built up the detail within that, we're now developing the BOMs. But as I said, the big part of our BOMs is the library. With Inventor for woodworking, what we don't want to do is be drawing up library components, because we reuse a lot of these quite a lot. What's key to a lot of this is not only the library components, but they're intelligent. There's more information on them within the BOM itself, with the supplier, for example, the make, the size. But one thing that's key in all this is that we don't want a solution where we put in the library component, then we have to put in all the holes for it to receive that particular component. So again, the standard library categories that we have within Inventor for Woodworking are fixing hinges, slides, as I said, and handles. But there's a lot more. And just to add, you can also add your own custom content in there as well. So if you're using anything bespoke, again, some example, cam types, and again, the next one, Cormac. So hinge types as well. And I might add, there's a big customer base there that we can put like Bloom and so forth like that we can download from their libraries and reuse. Big thing for me here with Inventor for Woodworking, that's a big time saver, is the fact that by using any of this hardware, that we do have the information, the resulting information that's required for manufacturing, such as hole depth, hole type, that type of thing as well. And any clearance or dowels that we know that those diameters are already taken care of, and the allowance will be made in those particular sheets as well. Along with obviously all the particular joints. Again, in this case, this is kind of a live example video of this, where again, what we're going to do now is we're going to pick a certain component, we're going to look at some hardware and place some hardware from it. Before we do that, we define where we want that hardware. Again, this is a very straightforward process. What we do is we create some planes, that's just locator points. And what we then do is we isolate the components that we want to work with. In this case, you can see we're coming along, creating the center plane along there, same on the other side. And once we've done that, now what we can do is we can establish what kind of hardware we want to use. So in this case, we're going to pick a joint, and it's going to be a hinge joint, and we're going to pick different parameters. On introduction of that, we can select the size, type, depth, and so forth. Again, full control. But the idea here is that you're not physically drawing this in, you're just locating it where you'd like it to be, specifying the faces and the components that you want to place a particular connector to. And again, the locator on it. And once you attach, You'll bring those components in, and you can see straight away that that hardware is inserted into the assembly, and also the holes that are required in order to insert that hardware and for that for machining is also included in that as well. So again, we're calling, again, you can see all the relevant information, the fixture fittings, and where they are in relation to the layout and where they need to be. And you can go back, you can determine, you can swap out this hardware with another element of the hardware, for example. You can control the number of occurrences. You can control what is used in the hardware, for example. So all that information is pretty straightforward and clear, pulling from the library, as I say. So again, we can continue on here. And then again, what we can do is we can mirror this information over. You can see in the last part of the hardware here. Again, this is a connect for the corners. So again, we can specify face, and location. And straight away, we have that information. We have that connector in place with the relevant information that's required. So I think, Cormac, you can skip on here first. That's okay?
Yeah.
Okay, that's perfectly fine. Good. And again, we're repeating the same on the other side as well. Okay.
Right.
The BOM specification, as you're well aware, and what we've seen across the industry, and my own personal experience going into facilities or like yours, manufacturers like yourself, is that the BOM is critical. The BOM detail, the quantity, the volume, the size, all that information is critical in how we manufacture these components effectively. But the key thing, what we do find quite a lot, is that this has been generated manually in certain cases. So to have a fully fledged BOM from a derived 3D parametric model with all its library components defined and the material that's required to use, both from a nesting point of view, and again, on top of all this BOM, we can control this within the ERP system to assign tasks. For example, if it's routed CNC, we can pre-purchase stuff for a particular project in relation to this, as you're well aware. But the idea is that if there's any changes, any subsequent changes to that 3D model, that the bill of materials is automatically updated and reflected as well at the same time. So there is no mismatch of communication. And back to Cormac's point about a connected workflow, with seamlessly workflow from the design to manufacture right through the end product is key to all this. And that's why the BOM is critical. Cormac, would you mind moving on to the next one, please?
Yeah.
So again, in this case, what we're doing is we're looking at material types, we're looking at veneer finishes. Not only are we talking about the physical elements of the material or the physical components that make up this particular design, what we're really looking at is we're looking at how we can change, how we can define that, how we can change different finishes. And we can make those different finishes on a customer request. How is that brought down into the BOM and detailed in the BOM? Again, Cormac, if you don't mind. So this is a kind of a prime example of this. In actual fact, I don't think we got to show this in the last presentation. This is exciting stuff. So what we can do is we can change the veneer type. We can source the components. We're pulling from a central database at all times. But this is a central database. So once we make a modification to this database, it's applicable to all the users within that organization. So we're working off a standard basis. So again, in this case, what we're pulling this information. We're defining the component. We're specifying the appearance type. Pulling from a centralized Excel sheets, and we can say what's mapped and what's not. And again, all this information is what we call metadata, which is critical to the process, which ultimately gives you a fully intelligent BOM used going forward in manufacturing. Again, pulling from a list of suppliers, so list of finishes, that kind of stuff. So we include a lot more detail in this, but you can see in the background, once we select, it will update in the background as well. So it's updating the model live as we do this. So again, not only are we updating the appearance for, say, an end user, for a customer to review or share, but we're also getting that into manufacturing intelligence straight off the cuff when we do this. So you can see here in the background, this material is being updated. Thank you, Cormac. Yeah, I think we don't need to, there's some repetitiveness in some of these videos, but this is kind of the output. But not only are we getting the output, we're getting the product structure. We're getting the instruction, the instruction scenario or procedure, I should say, around that, and the substructures, all detailed and all structured out as much. And again, like any finish, and you get a finished bill of material as well in this, so I do apologize, I'm rushing through this as well. So again, that's a fully fledged bill of material that we can then use, that is tracked and audited. And you can even import that back into your model again as well as my dad. Cormac, if you wouldn't mind pushing on that?
Yeah, you just mentioned there you can apply the costings as well, Ray, at this point, so each individual component or sub-assembly or assembly can be costed out quite easily.
Correct. My apologies. That's a very critical element of it, to be fair. So again, you can see now that the model is being updated in the background there as well. and we're adding, and we can then create our own templates. And if there's another configuration of that, with maybe a different finish, we don't have to recreate all that again. We can just pull in the bill of materials, generate a bill of materials off that, and that will give you kind of another bill of material that you can go with different finishes for different customers. So if you've got a standardized component and stuff like that, that's very critical. And again, you can see for manufacturer, you get the thumbnail information and so forth like that. So I think, Cormac, we can move on again, please. One thing that's very important, obviously, for manufacturer is the fact of automated drawings and annotations. There is a built-in library, industry standards of how drawings are annotated for your industry, as we're well aware of, and we can reuse those. You can customize that as well. But things like hole details, annotations, dimension styles, that kind of stuff, all that information is covered, and we all annotate the drawings as standard. With working for Inventor, when we generate a 3D model and we want to generate the automated drawings annotation and prepare for manufacturers such as testing and for assembly, there is a built-in component that's a comment. If you wouldn't mind moving on to the video, please, if that's all right. So in this case, what we can do, in this case, what you can do is we're now looking at basically an auto-plot functionality directly built into Inventor for woodworking that allows us to pull each individual component. We can change the settings, we can look at the outputs, we can specify the sheet size, what's in the title block, what information, what's critical information do we need to show on the drawing, joint fittings. And again, one of the big things obviously for manufacturer is layer colors, how machines receive information, how you bring in that information is used. So again, in this case, you can see we can just go through all the different kind of standardizations on what we want to export and so forth like that, and even produce PDFs and DXFs and so forth like that. So in this case, as we go through the model, you can see very quickly, you just pick up the information to start building up a base of sheets, the layout sheets, but it also sees all the manufacturing detail automatically. This is just one click of a button that we just did. So once we have a 3D intelligent model, we can generate the annotation drawings very, very quickly. Second to that, again, going back to update the model and connected workflow, these annotation drawings will automatically update and any changes that may come in subsequently. So again, very quickly, we can go through, but one thing that's very important is the title block detail and the metadata that I just spoke about, which is in relation to showing as much information as possible for the floor, material type, volume, that type of stuff, which is all there as well. Okay, Cormac? As you can see here with the CNC for manufacturer, there's quite a lot in there. We talk about nesting, we talk about the approach to nesting quite a lot with customers as well, and how we get the most out of it. So there's a lot of areas, a lot of, I suppose, nesting solutions that we can connect with directly. We use our own inbuilt nesting solutions as well. So in this case, we can define what is the workpiece, for example, what size to cut, or what face to cut from, what origin point to cut from, that type of stuff. So we can very much define the manufacturing process directly in the application. So you're bringing the designer more into the manufacturing element of it as well to make sure that they're aware of the process and that we're not designing something that maybe may not be able to be manufactured, I should say. But in this case, you can see we can determine which face, the double action. So we have one face for nesting, and then we have a second face for nesting, which we need to include some sub-processes like hole drilling, so forth like that. So again, this is very, very quick and easy to do. So we can define that process. And ultimately what we end up doing is we end up getting a full list of sheets, and we can specify what we exported, what machine type we want to use. We have multiple post-processors built into this as well. So, and again, if we don't have in there, it's very easy for us to bring them in and work with you on those post-processors as well. You can see here, we're just creating that, bringing it into the project, and we're just making sure we're getting everything set up so we can get it down to the floor in time. So once we generate it, you can see you can bring in the model. So all this information is brought in. So this is just something that maybe the CNC program on the floor, which will give you all the manufacturing detail and intent of our particular design in one operation. So again, remember all those sheets that we had. This is a reflection of that. This is the manufacturing sheets that you would see. So you can see all the information as you can see there on the screen. I think, Cormac, can we? Yeah. So, Cormac, would you like to?
Yeah, just some of the key functions of Inventor, Woodwork for Inventor. Design the complex and unique furnitures as well as standard cabinet furniture. So a lot of features and functions in there to allow us to, get really involved in the design and to optimize the design process. The assignment of materials, main material and cover materials. So we showed there how the breakdown of the part, where we end up with a single component or single part, but we can break it down into multiple different iterations. So, and the bill of materials is reflected accordingly. Visual materials adjustments, gain direction, technology oversize and edge banding. So you can obviously change the visual effect of those as well. And then the hardware assignment, automated placing, so that when you insert your hinge, it'll create the hole as well associated with the correct clearance and so on. The joint processing, hardware hole generation, solid wood joints, all managed and designed effectively within Woodwork for Inventor. And then the automated bill of materials generation using customized Excel templates, which obviously again can be used further downstream in terms of ERP, or maybe for costing purposes or for finance purposes, and so on. Automated drawing generation using customer drawing templates obviously is a feature of Inventor, but obviously more detailed feature then of Woodwork for Inventor. So that's our typical workflow there. We have the modeling process, then we have the kind of allocation of the parts, the creation of the parts, and the assembly, adding names, and then we end up with our bill of materials. That bill of materials then can be pushed down for drawings and then ultimately out to CNC for machining. We have the ERP component as well in there, so that we can take our bill of materials, drag it into our ERP system, and you know, maybe assign costs or different part numbers or individual components and replace them accordingly and push it back down into this existing workflow. Some of the key advantages of Woodwork for Inventor: 90% less mistakes. Woodwork for Inventor automates many routine tasks that the designer would normally have to do manually. There's a 60% improvement in time, use of time. Woodwork can save inventors up to 60% of their designer's time because of its ability to automate the drawings and comprehensively create cutting lists and CNC program generation. And also, as we said there, eliminates the human error as well in the rework. And Woodwork for Inventor allows the designer to generate a rich report on every single click, so the bill of materials and the reports can be presented and created quite relatively easily, and obviously they're updated as the design changes as well. So if there's modifications to the design, the reports and bill of materials will update automatically. So there are a few examples that are renderings from Woodwork for Inventor. So obviously some examples there. So a very useful tool, I think. It's added a lot of value to Procad's customers, and it's added a lot of value to the industry as a whole. We're hoping that it'll be a successful product here in Ireland as it has been across Europe. So, well, yeah, that's it. Ray, anything to add on that?
Okay.
Sorry, Bill.
Thank you very much. I think that has been hugely illustrative and very, very interesting. Just one question, if I may, there, Cormac. Approximately how much training time is required to introduce somebody who's already reasonably computer savvy to this network or to this software?
Okay, so if you're kind of taking from the beginning, where most people are savvy, we'll say, with maybe AutoCAD or some equivalent product, or maybe an alternative product to Inventor, it takes about 3 days of Inventor training, which typically to get up to speed with part creation, assembly, modeling, and also generation of 2D drawings. So that's about a 3-day course. So we've usually broken, historically we would have broken it down to 2 days and a follow-up 1 day, but now we're doing 5 days in the trot now, 2 hours each day with support thereafter. So we're actually getting through the course maybe in fewer hours, but it takes a little bit longer over time. It's 5 days instead of 3, but a shorter day. That would get you up to speed with your core Inventor skills and capabilities. The Woodwork for Inventor component is very, very specific and specialized, and obviously requires a level of industry knowledge. So obviously that would be a factor in the user's adoption of the software. But it's about 2 days of training, I think, is the complete package. So again, broken down into 1 day to get the basics and kind of get an understanding. Come back after a while of using it and seeing if you can, if you want to move on to the next stage, the next level. But it does require a bit of practice in between. So most companies who have adopted, I think, have managed to kind of get it up and running and functional within a number of weeks, we'll say, if they've kind of pushed it fairly hard. But other companies have adopted and kind of spent maybe 2 months or 3 months before they've added their own libraries and components and customizations. But it's quite user friendly, it's intuitive, and it works, you know, and it does save time, and that's the most important thing at the end of the day.
Thank you very much, Cormac. Thank you very much for the presentation. Cormac, I'm going to leave that now because I see that we have Jerry McGee there. Jerry, can you open up your mic?
Yes, everyone can hear me okay?
Yes, we can hear you.
Yeah.
Would you relate to the problems you've been having in relation to deliveries this week?
Yeah, I'll move on to that now, Bill, in a second. I just wanted to thank Cormac and Ray for the presentation. Just a small question, I suppose, regards, the best service for our members and that, and the best process. There's so many choices out there. I'm just, compared to your competitors, and making sure that we're looking at the right directions. Like, how does it compare to, I'm just going to throw it out, to, let's say, IMOS as a drawing software, which is very specific to Woodwork, and maybe some other ERP softwares, like, which brings everything together. I think service is a big part of your business, which I see to back these products up, but we just want to make sure, I suppose, it's definitely right for tailored joinery manufacturing and processing when it comes to bespoke curved work. We're seeing a lot of square detail and finish in that. So I suppose a simple comparison against maybe IMOS, what's the pluses and minuses in maybe a few touch points? Okay, well,
Without comparing directly to another solution, I suppose what we can talk about is Inventor and the Auto solution and the add-on Woodwork for Inventor. I suppose the most, it is a mainstream product and used across multiple industries, so it's quite adaptable. And what Woodwork for Inventor has done is made it very specific and customized. So it's added a very specific flavor to what would be possibly considered a generic tool across multiple design industries. Woodwork for Inventor has harnessed that very well and taken all of the typical day-to-day activities that a designer might encounter and combined them into one single solution. It utilizes all of the core functionality of Inventor when it's doing that. Advanced functionalities such as iLogic, which a lot of our existing customers would love to try to get into, but because of the amount of time and investment required to customize for their product range, it proves costly and more difficult. So what Woodwork for Inventor has done is actually harness all that information and combined it and packaged it all up together. And you can see from the demonstration from Ray there that it's a very thorough solution in terms of it starts at the very beginning and finishes with the actual specified final component, including every step in between, from visualization, simulation, and also the CNC and nesting as well. So it's a very complete end-to-end workflow.
That's super.
And it's cost effective. So,
do you mind if I just add to that very quickly? I appreciate that the presentation did very much cover, like, suppose standardization designs, we call it, something that we reuse quite a lot. But what we've got to remember here as well, it's also got the flexibility to do a lot of bespoke stuff. So you need that. We need to realize, I should say, that, you know, when we provide a solution to a business or to organizations like yourself, you do need the flexibility and you do need to scale with the business at the same time as well. So not only are we working with library information and working with shelvings and use stuff like that, we've got a whole flutter of features and products within there that can take care of your bespoke stuff as well.
Yeah, that's excellent. Thanks for answering that question. I suppose Bill wants me to move on to, I suppose, some of our members are